Okay, this is lesson 7.3, double angle formulas. Double angle formula shows how trig ratios for double angles are related to trig ratios for the original angles. So a double angle is just 2 times any angle. So for example, the double angle formula for sines shows you how a double angle for sine is related to just sine of an angle and cos of an angle. And the relationship is that sine of 2 theta is equal to 2 sine theta cos theta. There's double angle formula for tan as well, and then there's actually 3 different configurations for double angle formula for cosine. And it's just because we could use other trig identities to make other convenient representations of the double angle formula for cosine. What this video is going to be about is I'm going to demonstrate where these double angle formulas came from. The second video will be how to use the double angle formulas. So this double angle formula for sine actually comes from the compound angle formula for the sum of 2 sines. So where that is shown is if I were to demonstrate this by working with just the left side, sine 2 theta. 2 theta is just the same as theta plus theta. And then this looks like a lot like the sum of sines. And if I show you the sum of sines from our last lesson, sine A plus B is just sine A cos B plus cos A sine B. So if I use the addition formula for sines, I can expand sine theta plus theta. And what I would get would be sine theta cos theta plus cos theta sine theta. Sine theta cos theta is actually the exact same thing as cos theta sine theta, because when you multiply 2 terms, you can multiply them in either order. So I can rewrite this as sine theta cos theta plus sine theta cos theta. And when you have 2 identical terms, they're like terms, so you can add them. So sine theta cos theta plus sine theta cos theta is just 2 sine theta cos theta. And that's the right side of our identity. So that's where the double angle formula for sine comes from. The double angle formula from cosines actually comes from pretty much the same place. To work from the left side, cos 2 theta is the same as writing cos theta plus theta. And the addition formula for cosines looks like this. Cos A plus B is just cos A cos B minus sine A sine B. So cos, our A is theta, theta cos theta plus, nope, that's wrong, minus sine theta sine theta. And cos theta, multiplying 2 terms that are identical, is just cos squared theta. Now that's different than cos theta squared because it's not the angle that's being squared. It's actually the function that's multiplying by itself. It's like multiplying x by x. It's x squared, right? The function is x, and x is being squared. Same with sine. Sine theta is just sine squared theta. So what we have here is the right side. So where does the double angle formula for cosines come from? Well, pretty much the same place as the double angle formula for sines. They come from the sum of sines or the sum of cosines. A couple identities that it's valuable to remember for now are the Pythagorean identity, which says that sine squared x plus cos squared x equals 1. And you can replace the x's with thetas if you want, just a designation for angle. That tan is sine over cos, and then the 3 reciprocal ratios. Cosecant the reciprocal of sine, secant the reciprocal of cos, and cotan the reciprocal of tan. And these are a few other valuable identities that we're actually going to use in our next lesson, 7.4, to prove some trig identities. Three more formulas for your toolkit when demonstrating or proving trig identities, and also when solving trig equations. The reason there's 3 configurations for cosine is just these are just manipulations using the Pythagorean identity. So if you wanted to write this whole identity just in terms of cos, you could replace sine squared theta with, well, 1 minus cos squared theta, and then collect like terms. If you wanted to write this just in terms of sine, you could replace cos squared theta with, well, 1 minus sine squared theta. So these other versions of cosine, the double angle formula for cosine, the reason they exist is just so if you need to write cosine or cos of a double angle in terms of just cosine, you can. If you want to write it in terms of just sine, you can. If it doesn't matter and you want to write it in terms of sine and cos, you can too. It just gives you variety in what you can do with a double angle and cosine. So that's it for part 1. I'll see you in part 2.